Okay, from now on, I will explain about desizing. Desizing is one of the easiest and common enzyme used in textile. Okay, during weaving, fabrics are coated with starch to strengthen the yarn, but this starch must be removed before further processing. In enzymatic desizing, the enzyme amylase is used to break down the starch into smaller, water-soluble sugars that can be washed away easily. This method is preferred because it works under mild conditions, use less water and chemicals, and help maintain the strength and softness of the fabric. And for overall, enzymatic desizing is an efficient, eco-friendly and gentle process that prepares the fabric for the next step, such as scoring, bleaching, and dyeing.
Bioscoring is an eco-friendly scoring process that uses enzyme instead of harsh chemical to remove impurities such as pectin, wax, and natural oils from cotton fibers. This process improves absorbency, softness, and overall fabric quality while reducing water usage and environmental pollution. Bioscoring is part of sustainable textile retreatment because it works under mild conditions, does not damage the fiber structure as much as chemical scoring, and produce less wastewater. The process of bioscoring in the textile industry is an example of quite modern biotechnology, which permit the advancement in methodologies of fibers processing to enhance the quality of the final product. The present investigations report the efficient bioscoring process by pectins obtained from an indigenous species of penicillium. Prior to this, the production of the enzyme was optimized, enhanced, and characterized. Bioscoring performance on sample of cotton fabric and fibers result in overall improvement of sample quality as compared to cotton, which was evident by decrease in fabric weight, tensile strength, stiffness, and thickness in the enzyme treat sample. Enzyme treatment also result in the finer, softer, and dissolved yarn.
Bleaching of fabric is an essential step in the textile manufacturing process. The main purpose is to remove color from the fabric to prepare them for further processes to achieve a bright and a clean white finish. There are common bleaching agents, which is hydrogen peroxide that is widely used for cotton and sodium hypochlorite used in synthetic blends. The benefits are to enhance fabric whiteness and to improve absorbency and softness. Also, type of textile bleaching, which is reductive bleaching, eco-friendly bleaching, and so on. Bleaching of fabric is a vital process that prepares fabric for higher finishing, dyeing, and printing. As the textile industry shifts towards understanding, advanced bleaching techniques become essentials.
Biostoning and silk gumming are both eco-friendly enzyme processes used to improve fabrics in a gentler and more sustainable way. Biostoning uses cellulose enzymes to create the faded look on denim without using harsh chemicals or pumice stones, which helps reduce water use, fabric damage, and pollution. Silk gumming, on the other hand, uses special enzyme to remove the serration gum from raw silk. This process makes the silk softer and shinier, while using fewer chemicals and less energy than traditional methods. Both biostoning and silk gumming shows how enzymes can replace harsh treatments and make textile process more cleaner and more environmental friendly.
Today I will be talking about nanotextile and their role in sustainable textile development. Okay, firstly, nanotextile are fabrics improved using extremely small materials such as nanoparticles, nanofibers, and nanocomposites. Nanoparticles add functions like antibacterial protection, UV resistance, and water repellency with minimal chemical use. Nanotextiles are important because they support sustainability. They reduce chemical usage, save energy, and produce longer-lasting products, which helps lower risk and pollution. They also improve fabric performance in an environmentally friendly way, making nanotextile a smart and green solution for the future. In conclusion, nanotextiles show how advanced technology can lead to a more sustainable textile industry.
Nanomaterials significantly enhance the durability, stain resistance, and functionality of textile. According to Shimley and Lydia, 2017, nanoparticles such as TiO2, CNO, and SiO2 strengthen fiber structure, increase tensile strength, and create hydrophobic surface that repel water and oil-based stain, resulting in self-cleaning fabric. So, nanotextile contribute to resource efficiency and waste reduction. Thin nanocoating reduce water and chemical usage during finishing, improve fabric lifespan to decrease frequent replacement, and lower energy consumption by reducing washing frequency.
For question 2A about the environmental impact assessment, the environmental cost embedded in production and disposal of traditional fashion. At this point, the concept is fast fashion, which is driven by rapid trend cycle and low production cost. This model encourages consumers to buy more clothes more often. The consequence is an unprecedented volume of clothing produced and subsequently discharged, which can create a massive fabric waste. For question B, for nanotextile footprint can be enhanced properties like self-cleaning and antimicrobial function. For example, self-cleaning fabric is engineered to resist dirt, water, and oil. As demand for sustainable, smart, and low-maintenance clothing grow for both consumer and industry. On the other hand, conventional textile footprint is an encompassing measure that contributes to global carbon emission, water pollution, and waste generation. Conventional clothing relies heavily on the synthetic and conventional fibers like polyester and cotton, which are produced using intensive farming method that require vast amount of water and chemicals like fertilizers.
In conclusion, based on this chapter, biostoning, silk gumming, and nanotextiles all show strong potential to support sustainability and in textile processing. Biostoning uses enzymes to fade denim without harsh chemicals, while silk gumming removes serration gently with less water and energy. Nanotextiles also contribute by using nanomaterials to make fabric stronger, more durable, and more functional without needing a lot of chemicals. These improvements, such as better stain resistance, antimicrobial properties, and water repellency, help fabric last longer and stay clean with less washing. This eco-friendly process reduces water use, lower energy consumption, minimize chemical pollution, and create less waste.